In this problem we have the function f defined by f of x is 1 over x cubed, and we're given the Maclaurin series for f, which is 1 minus x cubed plus x to the 6th minus x to the 9th, etc. And it converges to f of x whenever x is between -1 and 1, non-inclusive. The first thing we want to do is to find the first three non-zero terms and the general term for the Maclaurin series for f prime of x. So f prime of x is just going to be the term-by-term derivative. F prime of x will be 0 for the first term minus 3x squared plus 6x to the 5th minus 9x to the 8th. Now, the general term is just going to be the derivative of the general term of the original function. So we would still have -1 to the nth, then 3n comes down, and we have x to the 3n minus 1. Now, you might notice that when you use values for n, that 0 is not going to work here. And it may be because the first term of the derivative was actually 0, and so because of that, we're actually going to start our terms with n is equal to 1 here. And not that that matters, but that might perplex you when you look at the general term. N would have to start with 1. And it's in all likelihood because of the 0 found by the first term of f, taking the derivative of the first term of f. Alright, the next thing that we want to do here is to use our results from part A to find the sum of the infinite series. Now, what we have there looks very close. The signs are all in the right places. The 3, the 6, the 9 are all in the right places. The exponents, square, fifth, eighth power, are all good. In order for us to get that numeric series from our f prime of x, we would have to be using f prime of 1/2. X would have to be 1/2 in that case. And in that case, we would get -3 times (1/2) squared plus 6 times 1/2 to the 5th minus 9 times 1/2 to the 8th, which would come out to be -3 over 2 squared plus 6 over 2 to the 5th minus 9 over 2 to the 8th, and there we have it. So what we're saying is that that infinite numeric series is just f prime evaluated at 1/2, and from that point we can depart from the series because the series are not going to be able to, that's not a geometric series that we can find the sum of. Actually, it turns out, I believe it is a geometric series, but it's going to be much easier. We could use let's just see one second. Say this is geometric, and it turns out to be negative. Now, it's not geometric because to get from 3 to 6 we need to multiply by 2, but to get from 6 to 9 it's not going to work. So this is not a geometric series, and so we can't go down that avenue there. Now instead we have another way, that is, we know that f of x is 1 over 1 plus x cubed, and therefore f prime of x would be negative 1 plus x cubed to the negative second times 3x squared, which would be negative 3x squared over 1 plus x cubed to the second power. And at that point, we could evaluate f prime of 1/2 to be 3 times 1/2 squared, negative 3, times 1 plus 1/2 to the third power would be 1/8 quantity squared, and that would leave us with negative 3/4 over 9/8 squared, which would be 81 over 64, and that would be negative 3 over 4 times 64 over 81, and that would give us negative 16 over 27. So we knew the original function, and we can find its derivative, and we can plug in a half, and we can get a value for it. So when that's possible, then that's a great way to go about this. So that's going to do it for parts A and for parts B.